Desalination of seawater using graphene. Desalination is a process where minerals and salts are removed from seawater to form pure water. In recent technology, scientists have developed a membrane called graphene that is set in water, which is put under pressure in order to filter the impurities. It just so happens that water molecules are small enough to pass through the membrane, while other salt ions are too big.
Using a computational tool called molecular dynamics, we've modeled the behavior of salt water flowing across graphene membranes at the atomic scale. Our simulations show that graphene could let water through at more than 100 times the permeability of existing membranes while still rejecting salt. The way to achieve this is to introduce small pores on the order of 1/1000th of a meter in the structure of graphene. If the pores are wider than water molecules but still narrower than solvated ions, our calculations demonstrate that water is able to flow across them while salt is blocked. And because graphene is one of the strongest materials known, this membrane could withstand the pressures required for water desalination.
One of the main benefits of desalinating salt water using graphene is that it does not require much energy. Although it may seem like we have a ton of water to drink, less than 1% of Earth's water supply is drinkable. So with this new technology, our global water resources could increase drastically. Plus, the water produced by graphene would satisfy our needs for drinking, farming, transportation, heating, cooling, and industry. The benefits that come from water desalination using nanoporous graphene vastly outweigh the cost of filtration. But what is graphene? It's a wonder material that is a sheet of graphite only 1 atom thick, and on the atomic scale, it's the strongest material in the world because of the strength and stability of the carbon bonds. It's transparent, but it can absorb light. It's also impermeable to all gases and liquids except for water, and it is the greatest conductor of heat and electricity on the planet. Graphene was first discussed in 1946 by Canadian physicist Philip Russell Wallace. He showed that if you stack enough sheets of graphene on top of each other, you get graphite, which is the material in your pencil. In 2004, physicists by the name of Andrei Geim and Konstantin Novoselov began to make graphene by sticking Scotch tape on a graphite cube.
Andrei Geim and Konstantin Novoselov created graphene using nothing but graphite and Scotch tape. They placed a graphite flake onto the tape, folded it in two, and then cleaved the flake in half. They repeated this procedure a number of times and then studied the resulting fragments. To their astonishment, they found some of the pieces were only a single atom thick.
Some benefits of graphene include that it can become naturally magnetic. This is useful in the production of computer chips. It also can be used to build stronger bulletproof vests, and it can be coated over any surface to make them more impermeable. And graphene can be used in DNA sequencers, and it can be used to build more efficient solar panels. But this is child's play for graphene.
This could lead to faster computer chips, longer-lasting batteries, wearable solar panels. Imagine battery-powered electric airplanes, cancer-detecting nanosensors, unlimited supplies of cheap desalinated ocean water. The possibilities are limitless.
Okay, so by now we know graphene is a major improvement in the desalination technique, and also in other many technological advancements. But what's stopping us from producing this widespread? Well, graphene is incredibly difficult to manufacture because it's so small and it's only 1 atom thick. And it's the most expensive material on Earth because 1 square millimeter of graphene can cost up to $1,000 to make. In desalination, impurities can grow onto the surface of graphene, causing the membranes to be clogged, which is called biofouling. Some of the old technology that was used for desalination was vacuum distillation and a process called reverse osmosis. A long time ago, the desalination process that was most prevalent was vacuum distillation. That's where water plants would heat up the water under really high pressure and then extract the salt water from the fresh water. But however, this process was really high cost and high energy consuming. Now the most prevalent technique is reverse osmosis. It utilizes a semi-permeable membrane to filter out the salt ions from the pure water when it's under pressure. The water will go through a cylindrical tube through 3 or so polymer membranes under pressure, and the salt ions won't be able to fit through the membrane and only the water will come out. And this filters bacteria, salt ions, and viruses. And graphene is a better option because the process is cheap and graphene is impermeable to every substance except for water. I believe graphene is going to revolutionize the medical, environmental, material, and computer technology. But most importantly, I think the enhanced impermeability of nanoporous graphene could be a major factor in revolutionizing the existing filtration technology of desalination, which would give us a seemingly unlimited supply of water to the world. Although there is still much research needed to be done, I'm very encouraged by the existing results of graphene and hope to see the technology improve in the future.